Lesson 7-3, Rational Exponents. Our essential question is, how do you solve an exponential equation? And our vocab word is also exponential equation. What an exponential equation is an equation with an exponent that is a variable. Okay. So our first examples, these aren't equations yet. These just say to simplify, and we have four different terms, four different numbers that have exponents that are fractions. So the first one is 64 to the 2/3 power. Now, when you're working with a fraction as an exponent, the bottom number, if you remember in our lesson from day one, the bottom number when it was a 2, that represented a square root. So remember, the square root of x was x to the 1/2 power, or the cube root of x was x to the 1/3 power. So the denominator of the fraction, the denominator represented the root. The numerator of the fraction represents the exponent on the variable x. So the square root would be like the square root of x to the 1st power. That would be x to the 1/2 power. Or the cube root of x to the 1st power is x to the 1/3 power. So all that we're doing here in this part of our lesson is we're changing the numerator on those fractions. So I'm going to kind of shrink this and keep it up here just as a reminder as to which part of the fraction goes where in our expression that we're evaluating. So 64 to the 2/3 power. So we could say that's the cube root of 64 squared. Now, 64 squared, that's going to be a really large number. If you're using a calculator, you could put in 64 squared and then you could find the cube root of it. A different way to look at this problem would be to think about our numbers that we worked with, like maybe the number 2, like we know 2 to the 2nd power is 4, 2 to the 3rd power is 8, 2 to the 4th power is 16, 2 to the 5th power is 32. So I'm just going to kind of write some of these powers that we have worked with already, because you kind of want to be able to memorize some of these as time goes on. Okay, so you may notice from what I just wrote that 64 is the same as 4 to the 3rd power. So instead of thinking about this in the radical form, I'm going to think about it as 4 to the 3rd power raised to the 2/3 power, because then those exponents, when you multiply those exponents together, the 3's are going to cancel out. The 3's, because remember when you multiply fractions, you multiply your numerators and your denominators. So this would be like 4 to the power of 6/3. So that's 4 to the 2nd power, or 16. So with a calculator, you could evaluate this radical, but without a calculator, you really want to have a little different method to work with. So I think it's a little bit better to know how to do this problem without a calculator, because you never know what you're going to see in the future. The next one, we could write as a square root of 36 cubed. Again, that's going to be a really, really large number. So I'm going to just leave that one alone. That's writing it in radical form if we needed to write it in radical form. But to simplify it, I'm going to think of 36 as 6 squared. 6 squared to the 3/2 power. If you multiply those fractions, 2 times 3/2 is 3. So 6 to the 3rd power. 36 times 6 is 216. So that answer would be 216. Okay, the next one, 81 to the 5/2 power. So the bottom, the denominator is a 2, so it's a square root of 81 to the 5th. That does not sound good at all. That's writing it in radical form. To simplify 81, I see I've got 3 to the 4th power equals 81. So I could use that, see if that helps me out, or I could remember that 81 is 9 squared. So it looks like 9 squared is probably going to be the way to go here. So 9 squared to the 5/2 power equals, well, this one's going to end up being 9 to the 5th power. So that, if you needed to simplify even more, you would definitely have to use a calculator. So 9 to the 5th power, 59,049 would be our final answer. And the last one, 32 to the 2/5 power, I'm going to use this. So the bottom number, denominator is a 5, so it would be the 5th root of 32 squared, if we had to write it as a radical. Otherwise, to simplify it, 2 to the 5th power is 32. So to the 2/5 power, the 5s would cancel out, so it would just be 2 squared, which is 4. All right. Now we have some equations. So 5 to the power of x equals 125. 5 to the 1st power is 5. 5 to the 2nd power is 25. And 5 to the 3rd power is 125. So 5 to the power of x equals 125. If I know 5 to the 3rd power equals 125, I can conclude that x equals 3. The next one is 6. 6 to the 1st power is 6. 6 to the 2nd power, 36. 6 to the 3rd power, 216. We saw that one on our last slide. So, if 6 to the power of x equals 216, and I know 6 to the 3rd power equals 216, again, x must be 3. The next one, 9 to the power of x equals 729. 9 to the 1st is 9. 9 to the 2nd is 81. And 9 to the 3rd, if I multiply 81 times 9, I get 729. So, again, 9 to the 3rd power, so x must equal 3 for all of these. So basically what I was doing is I was taking the base and trying to figure out what the exponent could be to give us that answer. Now we've got some equations that are a little bit more complicated. Kind of a lot more complicated. All right. So the first problem, we have 25. 25 to some power has to equal the number 5. Okay. 25 to the x minus 1 power equals 5. Well, I know my powers of 5. Like 5 to the 1st power equals 5. 5 to the 2nd power is 25. So I'm kind of thinking that I might use a method where I change this 25 to 5 to the 2nd power. Now, take a look at our problem. 5 to the 2nd power the x minus 1 power equals 5, or 5 to the first power. So now what I can do is, I can take my exponents, and I know that the exponent of 1 has to equal this exponent over here. So I am going to take that 2, and it has to be multiplied by the exponent on the outside, and then I can set it equal to 1. So 2x minus 2 equals 1, and I can solve this equation. So 2x equals 3 divided by 2, and x equals 1.5. 1.5. I could plug it in and check up here. So if I plugged it in, 1.5 minus 1 is 1/2. So my checking it would tell me that 25 to the 1/2 power has to equal 5. Well, remember that 1/2 is the square root, so the square root of 25 equals 5. So that is the correct answer. That is the correct answer. So my answer checks out. You don't have to do a check to check your answer, but you can if you would like to just be certain. Okay, the next problem. 12. 12 to the power of 2x plus 3 equals 144. Well, I know that 12 squared is 144. So on this one, I can change 144 into 12 squared, and now I can set those exponents equal to each other. So 2x plus 3 must equal 2. Subtract 3. 2x equals -1, and divide by 2. X equals -1/2. I'm going to check and make sure it's correct again. So if I plug it in right here, 2 times -1/2 is -1, plus 3 is 2. So then 12 squared equals 144. Perfect. That checks out. Make my work a little bit. Okay, the last one, 16. 16 and then 8. 16 is 4 squared, but 8, I don't think that will work. So I am going to check out my powers of 2. 2 to the first, 2 to the second, 2 to the third, and 2 to the fourth. And I think this is going to work out for us. So 16 is 2 to the 4th power. And then that's raised to the 2x minus 1 power. And then 8 is 2 to the 3rd power. So by writing them with the same base, we can simplify our exponents. So if the bases were different, I would not be able to set these exponents equal to each other. So it's very important that you can write both sides of your equation with the same base. So in the first problem, I wrote it with bases of 5, second one bases of 12, now bases of 2. So now I can take my exponents and set them equal to each other. I'll need to distribute again. So 8x minus 4 equals 3. Add 4. So 8x equals 7. So then if I divide, I will get 7/8. 7/8 for my answer. Now, if I plug that in up here to check, 2 times 7/8. Better get a little space here. Okay, so my exponent, I would have 2 times 7/8 minus 1. Because this is my original equation I'm checking. So I've got this exponent, it has to equal 8. Okay, so 2 times 7/8, so that would be, if I put a 1 under it, 14/8 and 14/8 reduces to 7/4 or 1 3/4. So 1 3/4 minus 1 would equal 3/4. So 16 to the 3/4 power equals 8 is what I'm checking. So remember that 16 was 2 to the 4th. So if I raise that to the 3/4 power, is that going to equal 8? The 4's would cancel, so 2 to the 3rd power equals 8, and it does check out. So look at the kinds of answers that we got for these problems, because we did not get really nice numbers. On the first one, when we solved it, we got 1.5 or 3/2. The second one, we got -1/2. And then the third one, down here, we got 7/8. 7/8. So getting an answer that's a fraction can be expected. And if you want to make sure that you've got the correct answer, just plug it back in and check to make sure that it's okay. You should be able to write a summary now and work on your homework problem.